And so while I totally hear you about it not being as easy for you guys, the engineers, when it comes to updating your SQL tables, it's the user that Django is ultimately going to benefit. And to an extent, it benefits you too, right? Because, like you say, once we do start dealing with more complicated stuff and more features in Django, you'll get to see the advantages of how it's all laid out. With that said, let's look at last cohort's slide deck and run through Django validators and tests. I actually wanted to see real quick. Yesterday you did, or not yesterday, but Tuesday, you all covered models, super user. Oh yeah, really basic stuff. Okay. Today should be a little more fun because we get to do some unit testing. Everyone loves tests. So we are going to set up a fresh clone, implement built-in and custom validators, create Django tests for models, and create validations for School API 3. For the walkthrough, we will be going through the Pokemon application. So feel free to do this along with me, unless you'd rather just watch. Let's see. Yep, here this should be the Pokemon Django example. So what I'm going to do is I'm going to copy this URL. I am going to go over to VS Code. Are you guys seeing all of this, or am I just showing? Okay, cool. Looks like you can see all of it. This is not the right project, so we're going to exit out of this. This is for week 14. Um, we're going to clone down our example. Let's actually run through the slide deck real quick because it's a lot. Yeah, we'll run it through it twice. I'll show you the slides, talk through the steps, and then we'll run through it again as an actual demo. And that should give you a bit of some repetition to drill in the exact process. So you already know how to set up a fresh clone, but we're going to go run through it anyway because repetition is key to memorization. You're going to create a fresh local clone and switch to the proper branch. You're going to set up and activate a virtual environment. You are going to install your requirements, and then you're going to run Docker Compose. We're going to be adding built-in validators, as well as writing a custom validator and running some tests. So the first step is what I just did in my VS Code, which is to clone the Pokemon example repo. We're going to run a git switch to end of the day 2, which I'll do once we go back to the example. We change directory into wherever we've set up our virtual environment, or if we have not set it up yet, then we run python-m venv, venv, and the directory that you want to create the virtual environment for. We then call the bin activate directory relative to whatever path you've installed the virtual environment in. We run pip install -r requirements.txt. We wait for that to complete, and then we are ready to spin up our Docker Compose, which should prepare our Postgres database as well as our Django application. The general steps for creating database models is basically you create your models, you add validators, and then you make migrations. You then apply migrations, and then you test, and you rinse and repeat whenever you need to add new models or make major changes to your existing ones. We're not going to be going over make migrations today. I believe Chad will have that covered this Saturday. Today, we're only concerned about validators and test models. So what that's going to look like is for the first part where we're using built-in validators, we are going to be importing some of our validators from the built-in Django library. And we are going to then call that validator, and we are going to pass in some requirements inside of the description field. We're going to then create a validators.py file. This is going to be for our custom validators. And then we're going to import this module called validation error. And this is how we're going to define our validations. We'll use a def block, pass in a name. We set our error message, and we set the method, let's say, that we want to run. In this case, it's going to be some regex. We then give an example of what is a good name. Oh, and let's actually backtrack a bit, talk about this regex real quick. So if you remember, or if you don't remember, the up caret in a regex, a regular expression, denotes the start of a string. And then in our square brackets, we've got a range of characters, capital A to capital Z, and then another set of square brackets to indicate a range of lowercase letters. And then we use the star, the wildcard, to say, repeat this or any number of instances of this until we reach $, which is the end of the string. So that is our regular expression. That's what we pass into this match method, and that is what's going to determine what a good name is. And if whatever the name is, once we pass it into this validation, if it passes, we return the name. Otherwise, we return a validation error. Once we've written our custom validation, we have to go back to our models.py file to import it so that we can use it. And in this case, we see that we're using validators in the parameter field for models.char field for the name, similar to how we used the built-in validator earlier. But in this case, we're going to be calling the validate name the keyword that we use to define our custom validator. All right, once you've written your validations, you've got to write your tests in order to test those validations. So we're going to make a test.py file, and we're going to add some more imports. We write out our tests. In this case, we have a test here where we will test for creating a new Pokemon. We pass in a name, a description, and then a try except block. So what we're trying is we're trying to assert that this name is longer than 0 characters, that it exists, basically, that it's not none as a data type. We first have to run full clean, the full clean method. Otherwise, the validator will not run on this instance. So that's what we're doing in this line. And if this passes, then hurrah. Otherwise, we have an exception that we raise, which is the validation error. We return the return of a fail method, basically. We then looks like this is just another test. Yeah, this is just another test. So that's about it. Any questions before we dive into VS Code? Does it seem
What does full clean do?
full clean? That is a good question because I don't remember myself. Let's go back to that slide and let's think about the context. Remember, validators are not ran on our new instance until we run a full clean. I wonder if full clean has something to do with what models are currently loaded. Let's see. Whenever we have no idea what we're doing, we reference our documentation. And in this case, validating objects. There are 4 steps involved in validating a model. We first validate the model fields. We then validate the model as a whole. Oh, it looks like the full clean will run all of these methods. So all 4 steps are combined when you run a model's full clean method. So let's break it down a little further and look at what these individual methods are. The first one, which is clean fields, will validate all the fields in your model. The optional exclude lets you provide a set of field names to exclude from the validation. So if we look at our example here, this method should be used to provide custom model validation and to modify attributes on your model if desired. For instance, you could use it to automatically provide a value for a field or to do validation that requires access to more than a single field. However, like full clean, a model's clean method is not invoked when you call your model's safe method. In the above example, the validation error exception was raised by model.clean was instantiated with a string, so it will be stored in a special error dictionary. What I'm particularly interested in relative to your question is why the validator will not run until the full clean is run. This is some Django magic that I do not remember. So maybe we can ask ChatGPT. Snap, I'm not on ChatGPT on this account. Let me really quick. I'm gonna pull up another window. You guys can see this. We want to ask ChatGPT, why can't I, okay, what was the exact context? Why can't I run a validator on an instance in Django until I run full? Okay. What ChatGPT says is in Django, running full clean on a model instance is necessary before calling save or running a validator because it triggers the validation process for all fields on the model. This ensures that all fields adhere to the field-specific constraints and any custom validation logic defined in the model's clean method. Huh. Does that make sense to anyone here? Yeah, me neither. It seems, oh, go on. I heard somebody. Was that a volunteer volunteering to interpret ChatGPT's answer? Because I'm hearing things. Let's see. Let's dig a little deeper into this. Okay, so when you call full clean, Django performs several validation steps, such as checking constraints, invokes the clean method. I mean, reading this, it just sounds like, well, it's logical. It makes sense that Django developers have designed it that way because they want to ensure that all data associated with the instance is properly validated before proceeding with any further actions, such as saving to the database. Okay, so that makes a little more sense because now we're giving it a bit of context. So I'm guessing the wording on this is just not the best because the answer from ChatGPT and the documentation makes it sound like makes it sound like the validations are called by full clean. And so within our test case, we're calling full clean to instantiate the actual validations. Does that make sense?
No, not really, but
Okay, so we've written out our validations, right? But we got to call the validations. In our test, we call the validations using full clean. Does that make a little more sense?
yeah, yeah, that makes sense. Okay.
Okay, cool. All right, let's switch over to VS Code so we can run through this live. And again, if you haven't started yet, or if you've started already in race, basically, we're going to go through all the steps we just talked through in the slide deck, and we are going to do it in VS Code live. All right, I've just cloned my Pokemon repo. I think there was something that I was missing, which was, oh yeah, I had to get switch into end of day 2. I might have to pull that specific branch first. So let's see if this works. It would help if I changed into the right directory. All right, I switched to a new branch end of day 2. Not sure if, let's take a look real quick at day 2. Make sure that we have all the necessary changes. Let's see. I'm just going to confirm by looking for a change here and seeing if it exists in my directory. So let's go into models.py, line 7. Yep, it looks like I have the latest changes because these red highlighted lines have been removed and the blue highlighted lines, like in line 11, have been added. So I'm on the right branch. I can move on to my next step. I am going to now I need to make a virtual environment. But it looks like I already have a virtual environment activated. So let's just do this. Shoot. Okay. And I've already seeded into my folder, I believe. Let me just double check. I'm gonna make my text bigger. Okay. Python-m v. I want to make my environment in this current directory, so I pass in a period. Now I'm going to call source bin v. Activate. Okay. I'm in my virtual environment, so now the next step is to run my pip install. Okay, looks like everything is good. I'm now ready to run my Docker compose up. Oof. I am going to go back to the directory I was in earlier, because it was the wrong directory. And I'm going to run Docker compose down on that. Okay, now I should be ready to go back to my Pokemon folder and run Docker compose up. Looks like everything is good so far. We are now ready to actually start writing some Django. So the first thing that we're going to do is add a built-in validator. That means we are going to go into our models, and we are first going to import from Django.core validators as v. So now I can use, let's say, a length validator inside one of these properties. Let's do, it's a good one. Let's do the description. I guess we don't have a description yet, but we can add one. So let's say description will equal models text field. And in this case, we could have a default value that's just an empty string. And now we want to pass in the validators that we want to use. So in square brackets, we call v, which is what we've imported the validators under. And we are going to access its min length validator method. We're going to pass in a parameter for that. And we do the same for max length. Oops. The reason this is an array is because we can have multiple entries. So max length indicator, let's give it, I don't know, 150 characters. And we save. We now want to create a validators.py file, which will allow us to write a custom validator. We're going to import from Django.core exceptions the validation error class. We're also going to import RE because we want to use a regular expression for our validation. So let's say validate name, we only want alphabet characters. So we're going to say error message will be something like improper name format or something like that. And then we'll pass in our regex. Again, we want to use our up caret to start the string, a range of characters we want to allow. We want both uppercase and lowercase. And we want to apply these rules to all of the characters until we reach the end of the string. All right, so now we've got our regex. We can use that to determine what is a good name versus what is not a good name using the built-in match method. And if the good name value returns true, then we return the name. Otherwise, we raise a validation error. We got to pass in the error message along with some parameters. Name will be the name that's being passed in. All right, I have saved, and now I can import this validate name into my models.py. So let's go back up to our import. Let's get a new line in there, and let's say from my validators file, which we are which we named as validators and which exist in the same directory. So we use a period to denote that. We import the name that we used, in this case, validate name. We then go to our name And just like with the built-in validator, we use the validator's argument to call our custom validator. In this case, instead of calling the built-in validator's variable, we are going to call validate name. And we save, and now we can go to our tests. So let's make a test, or we actually already have a test.py file, so we can just get started with our imports. We're now going to need exceptions. So we're going to import validation error. And then from our models.py file, we're going to import our class, which is called Pokemon. All right, now we can write out some tests. Class Pokemon tests. This is going to use the test case class that we've imported from Django.test. And we are going to say something like new Pokemon equals instantiating the Pokemon class and passing in parameters with a description. And I don't need quotes around that, so we delete that quote. And now we want to call a try except code block. And this is where we call that mysterious full clean method to actually summon our validations. So full underscore clean. Ooh, we have a description right here. What this does is it calls clean fields, clean, validate unique, and validate constraints on the model. So that's how it's running these validations. It's basically a super method that calls for other methods. So now we can say self.assert is not none. And we're going to pass in this new Pokemon that we just created. And if it returns false, then we want to raise a validation error. Any questions so far? Oh, I see that I am missing a line. Before we can create the Pokemon, we have to define what we're creating the Pokemon under, context, if you will. So we're going to say test 01, it's our first test, create Pokemon instance. When we create a Pokemon instance, we want to test and assert that the value for the name is not none. So need my colon, it's Python, so I need to indent. And now everything is hunky-dory. I'm going to save. And I believe that is it. Now we can run some tests. Let's pull back. Let's pull our, where is it? Okay, it's just the Pokemon example. What we need is validators and tests. We've run through pretty much all of this. We did custom validators. We did the built-in validator. We wrote some tests. Now we can run our Python.manage.py. Whoops. I want to create a new directory, or sorry, a new terminal to call this because I have Django running in this terminal. So let's get out of this directory. Let's go into Pokemon and let's run Python. Yes, I meant test singular. And it failed. All right, let's take a look at our test. In test 01, create Pokemon instance self.fail. assertion error equals none. Okay, what happened? Oh, my description needs 25. Okay, I guess. Um, I am, I have to come up with some silly description on the spot, and I can't think of anything. So we're just going to copy paste this numerous times. There should be, I think there should be more than 25 characters. So let's run our test again. Oh, it still failed. Is anybody running through this demo on their own machine? Want to know what kind of results everybody else is getting? Oh, it wants capture to be either true or false. Okay. We're gonna have to create some additional parameters. So whatever, we're gonna say this is true. And let's see if it fails again. Nice, it passed. So let's go back to our validators. Let's go back to our models. Oh, I see. We may not have called the validator for the captured parameter, but it uses a Boolean field, which is why it needs to either be true or false. Mystery solved. All right, any questions? Cool. I am going to set up some breakout rooms and you guys can go ahead, take a break. And when you get back, work in your groups on today's challenge, which I believe is School API 3. Cool.